This is a video on surface integrals. The question states, evaluate the surface integral over the surface S of 2x plus y ds, where S is a surface defined parametrically by r of uv is equal to 3u cosine vi plus 3u sine vj plus 4uk. And u is between 0 and 2, and v is between 0 and pi. So to calculate a surface integral defined parametrically, I first need to find the magnitude of Ru cross Rv. So let's find Ru first. So Ru is a partial derivative with respect to u of r, which is 3 cosine vi plus 3 sine vj plus 4k. R sub v is the partial derivative of r with respect to v, which is negative 3u sine of vi plus 3u cosine of vj, and then plus 0k. So there is no k component. So now I need to take the cross product of Ru and Rv, which is the determinant of the matrix I, j, k, and then 3 cosine of v, 3 sine of v, 4, and then negative 3u sine of v, 3u cosine v, and 0. So I need to take this determinant. So for the I component, I get 0 minus 12u cosine v. So I have negative 12u cosine vi. And then minus, for the j component, I get 0 minus a negative 12 u sine v. So I get minus 12u sine v j. And then for the k component, I get 9u cosine squared v minus a negative or plus 9u sine squared v. And I can factor out the 9u, and cosine squared v plus sine squared v is 1. So I just get 9uk. So there's the Ru cross Rv. I need to find the magnitude of Ru cross Rv. And to find that magnitude, it helps to factor out a 3u out of this vector. And what I'm left with is negative 4 cosine vi minus 4 sine vj plus 3k. And when I take a square root of the sum of the squares, I get 16 cosine squared of v plus 16 sine squared of v, and that's equal to just 16, and then plus 9, that's equal to 25, and the square root of 25 is 5. And remember, I had factored out a 3u, so 3u times 5 is 15u. So there's the magnitude of Ru cross Rv, which is 15u. So now let's recall that the surface integral of a function ds is equal to the double integral over the region of the function evaluated x of uv, y of uv, and z of uv times the magnitude of the cross product of Ru and Rv dv du. So I substitute in. We have our function is 2x plus y. X is 3u cosine v, and y is 3u sine v. So I get the double integral. And notice that u goes from 0 to 2 because u is between 0 and 2. And v goes from 0 to pi because v is between 0 and pi. And then we have our 2x, or 2 times 3u cosine v, plus y, or 3u sine v. And then Ru cross Rv in magnitude was 15u dv du. So I could work this out by hand. It's not that difficult, but instead I actually used a calculator And I got that this double integral is equal to 240. So I can conclude that the surface integral over S of 2x plus y ds, where S is r of uv, is equal to 240. And I'm done with the problem.